tree iterator, problem number 173 on Leetcode, and you are to implement the BSTIterator class. So you have to implement the constructor for this class and then two methods, one called next and the one next is called hasNext. So you're given the root of the tree in your constructor, and then you are supposed to keep track of a pointer and just say return. For this one, you can just say what's the next one, and this Boolean is going to return true or false whether or not there is a next one, given the root that was passed in the constructor. So it says you may assume that the next calls will always be valid. You mean that you don't have to check whether or not there is a hasNext before you return this next. So for instance, you're given this tree here. You would be passed this root, and then it would just tell you when you're calling next, you would return 3, then 7, then whether or not it has next, you would say true because you're not at the end of the tree. Then you would return 9. If you're checking if it still has another one, you will return true, then 15, and then 20, and then you're going to return false because you don't have any more nodes left. So you can see clearly that in this constructor, we need to keep track of an index. And instead of iterating through the entire tree, we can just keep a list too. So we need an index to keep track of the current position. And that would say the next would increment the index and return the value from that node. hasNext would check to see if you add 1 to the index, if there's still some left. So probably the best thing to do is to just take this root and we can just make a list from it. So what we would do is first just traverse through the entire list, the entire tree, add the values to a list, and then we'll just keep track of an index and just go through that. So when we call our constructor, you can add these objects here in this public constructor method, but I can even just initialize them right at the top. So we're just going to make an array list of integers. I'm just going to call it L. I'm going to initialize it right here. And I'm also going to have a new index, and I'm going to initialize it here too. I'm going to start the index off at -1 because I can always increment it before I call it. So let's just, I can come back to that, but let's just see how this works out. So the first thing we're going to do is just make a list from this root. And we can even make this a void because we have access to this list right here. So we're just going to say void, make this list, and it's going to be this tree node root that we passed through. We're going to just call this recursively. So for our base case, we'll say if root is null, we're just going to return. And we can just traverse this. So we could say, first we're going to go left, then we're going to add it, add this root value, and then we are going to go right. So that is, we're just traversing it. We're first going left, and then we're taking the center, and then we're going right. That's an in-order traversal. So this will be adding all of our root values in order as soon as the constructor is called. So we are going to say, start off with has next first. So we're just checking to see if from our index value, if we add 1 to it, is that going to be less than the size? If that is true, it'll return true. If it is false, then it's going to return false. And then to get the next value, we're just going to return the list, and we are going to get the index. But before we get the index, if we do the plus plus before, that is going to increment it before we access the index. So the first time the index is accessed, it's going to be a 0. The next time it's accessed, it's going to be a 1. So if we do this plus plus beforehand, then we can always access the right index we want. And then also we can use the index plus 1 here in case has next has been called first. That is going to start off at 0. So we're never going to access it as -1. But in this way, we're not changing the value of the index here. We're just checking to see if we have this index and we add 1 to it, is it going to be less than the size? We are going to actually change the value of the index here as we move to the next one. And so that is as simple as that. Again, if you have, there's different ways to initialize objects. You can just initialize them here. You can also initialize them within the constructor. Just initializing them here, and so there's going to be access to them when we do this traversal through the tree, and it's also going to be accessed here and here, so that we're not passing it as a parameter, we're just all accessing the same index. And let me run the code. And so that should work. Okay, let me just put this here. Okay, thank you.